we want to find the numerically greatest coefficient in 2x minus 3y to the power of 7. And here we have both x and y, but we've been told that x equals to 1 and y equals to 2. All right, so let's put it into that ratio of greater than 1 first. And you can see here, because we've been told that x equals to 1, this essentially is just 2 times 1, yeah? And that's what I've put into here. That's my a, essentially. Whereas over here, I've been told that y equals to 2, so that's 3 times 2. And that's my b that I've put up here, like that. And that was my a, okay? And this is a step that you need to substitute in your x and y's. Good. And now it's just some simplification. So we know that that 2 and that 2 will just cancel. 7 plus 1 will just give us 8. So that's why we have 8 minus k times 3. And that k has just been multiplied to the other side there. All right. Now expanding it, that becomes 3 times a is 24 minus 3k greater than k. Move the 3k to the other side. It becomes 4k. Divide both sides by 4. And we found out that for this to be true, k must be less than 6. Now, as soon as you see that k is a whole number, what do you need to think? Good. You need to think that we're going to have 3 scenarios here where k equals to 6, and that means that 2 terms are going to be the same, right? All right. So that means we need to consider the 3 scenarios where k is less than 6, k is equal to 6, and also when k is greater than 6. So firstly, for when k is less than 6, so that's 1, 2, 3, 4, 5, that's when k plus 1 is greater than k here. So substituting that in, you get that T6 is greater than T5, so on. Now the second scenario was that k equals to 6, okay? So if that becomes an equals to sign, then that becomes an equals to sign as well. So tk equals to tk plus 1. So therefore, substituting that in, we find out that T6 equals to T7 there, right? Now finally, our third scenario, which is k is greater than 6. So in this case, it's only going to be for 7, all right? Not 6 and 7, because 6 only belongs there. Can you see that? So only for k equals to 7. Substituting that in, you find out that T7 is greater than T8. So if you wrote that all out, what you would get is T6 equals to T7, and then being greater the numbers on either side, yeah? So therefore, this must be our numerically greatest coefficient. And then we just need to work it out, yeah? So work that out, that k equals to 5 in that case, and we just substitute it into our general term. And remember, because we've been told that x equals to 1, then this here just becomes 2 times 1. And we were told that y equals to 2, so that just becomes 3 times 2. Yeah, that's our only difference. So you have 7c5, this to the power of 7 minus 5, that to the power of 5. Calculator work, really simple. And that gives you 653,184. And remember how I said a really great way to check your answer for this is just to work out T7. So let's do that. For T7, I know that k is going to equal to 6. So it becomes 7c6, 2 times 1, 7 minus 6, 3 times 2, power of 6. Calculator work, and it's exactly the same as that. So you know you found both the 2 greatest coefficients for this equation here. So it doesn't matter if you have x and y as well, just as long as you know what x equals to and y equals to, just substitute it into your formula here, and then also remember to also substitute it into your general term formula down here as well. Now, some of you may notice for this question that although the question specifies 2x minus 3, in all our working out, we've been working with a positive 3 there. As well, when we substitute into the general term equation, we use positive 3. Now, why do you think that is? Well, it's because we have what we want to find is a numerically greatest coefficient. And do you guys remember I told you about that? That the numerically greatest coefficient means that we don't care about the sign, that we don't care whether it's negative 100 or positive 100. Negative 100 will be greater than 99. Yeah? So therefore, since we don't care about the sign, then we don't need to worry about that negative either. Because all that negative does is make it positive, negative, positive, negative. It doesn't actually change a number itself. So therefore, whenever you see the numerically greatest coefficient, you can just make that into a plus when you're working it out. Yeah? And over here, when we substituted it in, one of these would be positive and one of them would be negative. But it doesn't matter because for the numerically greatest coefficient, they're both equal to each other, even though one's positive and one's negative. Yeah, so this just saves you a lot of time and effort because it's more difficult to work with negatives. Whenever you see a negative here and it's numerically greatest coefficient, you can just change it to a positive.